The participate, this is some natural problems affecting I hope I was not audible earlier. So please let me continue with my introduction. So welcome you all for the day 4 of the Agile Online State SDG. So we all have very much privileged to have the ma'am here with us today. So ma'am is Associate Professor in the Department of Computer Science Engineering, College of Engineering. I'm completed BE and ME in Computer Science and Engineering from MS University Tirunelveli in the years 2003 and 2005 respectively. Sir, am I audible? No?
And your voice not clear.
Okay. Once again, please.
Ma'am, there is lot of noises. There is lot of noise. Hello.
Sir, wait a second, sir. Very fine. Good evening, participants. Is it audible?
Yes.
Yes, sir.
Clearly.
Sir, audible.
Yeah, welcome you all for the day 4 Atal FDG. It's our pleasure to welcome our today's resource person, Dr. DJ ma'am. DJ ma'am currently working as an associate professor in College of
Sorry,
Engineering,
but
India.
your voice not clear.
Sorry. Okay, fine. So DJ ma'am currently working as an associate professor in College of Engineering in Gindi. Ma'am has completed his doctorate in MS University with a research grant of granted by AICTE. Ma'am completed PhD in the year 2011. After that, ma'am worked as an assistant professor and head of the department in Anna University, Tirunelveli. Currently, ma'am joined associate professor in College of Engineering, Gindi. Ma'am has completed a lot of research projects and published many journals. In addition to that, ma'am received a Silver Award of Excellence in International Technology in Ministry of Ayush, Government of India. So, ma'am has published several patents too. So, we are having such an eminent personality for this today's session. So, we welcome Dr. DJ ma'am. Ma'am, please, session is yours.
Thank you, K. Saraja. Thanks for the introduction. Good evening to all the people who have joined. Hope I am audible.
Yes, ma'am.
Hope you are able to see the screen that is shared.
Yet, no, ma'am.
Not able to see the screen?
Yes, ma'am. Please share it again.
Yes, I'll do it.
Yes, ma'am. Now it's visible.
Okay.
Yes, ma'am.
Thank you. So, good evening, everyone. The topic that is assigned to me is data workflow in cloud. As such, I'm a new entrant to cloud. As such, I have already guided one of the research projects on resource provisioning in cloud, and that too some 8 to 10 years back. And after that, I have never ventured into that area. And as such, since the topic assigned to me is for today's session is data workflow in cloud, I didn't want to deviate from the topic. So I thought of giving you a quick introduction to cloud computing. Maybe people who are new to it may get an insight to what cloud computing. And
Ma'am, you are muted.
Madam?
Madam, you are muted.
yeah, should I start from beginning?
Yeah,
Yes,
yeah,
ma'am.
yeah. Please.
It's fine. Good evening, everyone. The topic assigned to me is data workflow in cloud. As such, I'm a new entrant to cloud computing domain. In the past, say 8 to 10 years back, I had worked on a research work of my scholar on research provisioning in cloud. And after that, I have never explored where cloud computing is. And since the topic assigned for the day is data workflow in cloud, I didn't want to deviate from the topic assigned. And so I thought I could go with a quick introduction to cloud computing. And then we'll be actually looking into what cloud data workflow is. So this is going to be the organization of the presentation. Let's see what cloud computing is. What were the early models to cloud computing, which actually motivated or paved way for cloud computing. Some of its delivery models and services it offers. What are the ethical issues in cloud computing? What are the vulnerabilities still? Of course, these slides I have added just because there is scope for further research to be carried out for any of those vulnerabilities. And one slide on parallel computing and distributed systems. And after that, we'll be moving into cloud data workflow, the platform and the architecture, its layers, what are all the components, and some example cloud data platforms. So first, let's see what cloud computing is. So what you see here is some of the standard definitions available in book. So as such, if you want me to explain what cloud computing in a sentence, so I would say that it refers to delivery of some computing services over the internet. And by services, what I mean is that it could be server, it could be storage, database, or networking, or software, or any sort of analytics and intelligence. So delivery of any of these services over the internet, we can call it as cloud computing. So the primary advantage of cloud computing is that we all know we need not own any of the physical hardware. Users will be accessing these resources as and when they require from any of the cloud service providers. So let's consider a real world example. For example, you can think of a small startup. They want to launch a new e-commerce website. So during the initial days of starting a company, people may not be interested to invest heavily on the setting up infrastructure like servers for databases and for the networking infrastructure. So in such scenarios, what they could do is they could very well leverage any of the cloud computing services. For instance, they can rent virtual servers from a cloud service provider like say AWS, Amazon Web Services, or Google Cloud Platform. I would be calling it as GCP hereafter, to host their website. So this will allow them to scale up their resources up or down depending upon how their business fluctuates. And there will not be any upfront costs. And they do not even worry about how to manage the hardware. So all these are some of the advantages of going for a cloud infrastructure. Apart from that, there are certain other benefits which we gain from cloud computing. Like one, I could say that it is cost effective, that we don't have to invest well in advance. It reduces upfront costs. And I could say that it is scalable. As and when you want to scale up the resource, you can do it in order to meet your changing demands. And then usually the providers offer a reliable service, which means if I host a website there, then it is going to be available all the time. And usually providers take care of taking redundant copies of the data, and so the downtime is usually close to zero. And the very special advantage of cloud computing is security, because providers, they themselves will invest heavily on security aspect to protect the data. And as such, this environment is flexible, that you can access data from anywhere in the world. The only requirement is that you need to have an internet connection. So this is about cloud computing. Now we'll see what are all the cloud computing models, resources, and attributes. So cloud computing deployment model actually defines the type of cloud environment based on ownership, the scale, as well as how we access. So there are four primary models. As you see, you could have a public cloud or a private cloud, a community cloud, or a hybrid cloud. Public cloud is one infrastructure, cloud infrastructure, which is made available to the public. So in a public cloud, all the resources will be shared, and users can scale scale the resources according to the need, and it is the most cost effective one. And in such case, the infrastructure will be managed by the provider. And the examples for public cloud is AWS, Azure, and GCP, right? And in a public cloud, by infrastructures, we mean it could be server, storage, networking, or software, anything it could be. And all these resources will be managed by the cloud provider. The next is the private cloud. In this case, the cloud infrastructure will be solely operated by a single organization, and it is for this particular organization. And so here we say that the resources are all dedicated, but since there is no interference from any other organization, so we say that the data is highly secure in a private cloud, and we can customize private cloud according to our requirements and need. And there are two options. Either you could manage your private cloud on your own, or you could use some third party provider to manage your private cloud. Both are possible. And in case of hybrid cloud, it is actually a combination of both private and public clouds. It takes the best from these two clouds, and its characteristic would be like it is flexible, scalable, and the security is high. And just because it is hybrid, data portability is also possible. And the last is community cloud. By community cloud, we mean a cloud infrastructure which is shared by multiple organizations. So here, if there is a need for collaboration, then it is good that we go with the community cloud. So here, the shared resources in a community cloud will be managed by some third-party provider, or it could be managed jointly by all the organizations. And then about the cloud service models. So these three words, phrases which we may be aware of it: infrastructure as a service, platform as a service, and software as a service. And so in infrastructure of as a service, provider will give us computing resources like server, storage, and networking. And in case of platform as a service, provider will give us a platform. And in that platform, the developers could develop their application, they could deploy the application. And because of which, people need not bother about setting up the platform. They can rather focus on application developments, and it actually greatly reduces infrastructure management aspects. And because of that, as developers focus more on application development, usually product reaches market much faster than we do otherwise. And in case of software as a service, provider will be giving you software application, and you can access that software over internet. And in case of software as a service, there is no need for any infrastructure management. It's very easy to use when compared to PaaS and IaaS. And in case of software as a service, the user as such need not even bother about updates to the software made every now and then. Everything is taken care of by the provider. And as such, cloud computing resources, we mean compute resources, which could be virtual machines or containers. By networking resource, we mean it could be virtual network or firewall. By it could be either database resources, like either a relational or a NoSQL database, or it could be some analytics resource, mainly for doing some data analysis operations. So you may even have some machine learning services. So all these are part of resources. And finally, about defining attributes. So by defining attributes, we mean that in a cloud, we usually call it as an on-demand self-service, where users can access all these resources independently, and they can access such resources from anywhere, and they can use any device to access that resource. And in a cloud environment, resources are actually pooled, which means the resources are allocated to users dynamically, and all those resources are actually shared. And it supports elasticity, which means resources can be scaled up and down depending upon users' needs. And in a cloud environment, we call it as a measured service, which means always the user's usage will be monitored, and user will be billed according to his usage. And these are some of the early models of cloud computing. We may be knowing all of these before. One is that we have grid computing. We know grid is nothing but a collection of clusters, and we normally refer to a heterogeneous computing environment as a grid. And in a heterogeneous environment, you will have both CPUs and GPUs, and mainly it is used for doing some complex scientific calculations. And we had mainframe computings also in the past. And in case of mainframe computing, very few people had the knowledge to work on mainframe computers. And as such, mainframe computers are powerful computers. Its resources are shared among multiple users, and users will be usually accessing mainframes through terminals, and and at specific time slots they will be accessing. And usually in a mainframe, access will be given to large organizations and institutions. And then we had client server computing in the past. We had distributed computing, and we had the concept of virtualization, where we'll be creating virtual machines on top of physical hardware. And resource sharing was also possible with the help of virtualization. And then we had utility computing back in 2005 to 2006. So in that case, all computing resources as well as infrastructure will be made available to the customer by the provider, service provider. And depending upon the customer's requirement, they will provide and they will charge depending on the usage. And so these are all the early models in computing, which actually laid the foundation for modern cloud computing. So only from these early models, cloud computing drew concepts like resource sharing, remote access, or virtualization. And this early models actually laid the platform for the development of today's cloud platforms and services, and with which we normally use in our day-to-day life nowadays. And these are some of the characteristics of cloud computing. As I mentioned before, cloud resources can be accessed by anyone. All that users should do is they should provision and they can manage their resources on their own. And in order to get access to any of the cloud services, it is sufficient that the user possesses some device with some internet connection. And as such, cloud is actually a shared resource. We can call it as a resource pool. So in that resource pool, you have server, storage, networking, etc. It is meant to be served for multiple customers. And as you demand, your provider will give you, the right allocation of resources for you. And cloud supports elasticity. In that sense, we can scale up or down the resource depending upon the fluctuating demands. And it is a measured service, as I said before. You will be metered for your usage. And then we move on to some of the advantages of cloud computing. Like one is we have plenty of resources available, and we'll be paying for what we use. And it greatly reduces the cost on infrastructure which an organization should invest. And it greatly minimizes their expenditure on hardware, software, and availability of IT personnel to manage those hardware and software. And scalability is one of its advantage. And performance will be highly improved. As I said before, providers usually have a robust infrastructure, and they usually guarantee zero downtime. And performance also, the performance of cloud will be extraordinary, that you can even witness faster processing speeds. And security, when we talk of security, as providers, they will have the best security measures with them to protect the data. And they will usually focus on keeping the infrastructure as well as the software up to date with latest security patches also installed. And it is highly flexible. And as I mentioned before, if developers have PaaS, that is platform as a service, then it frees the developer from worrying about the platform, and they could focus fully on the development and deployment of an application. And it offers better collaboration, which means there are plenty of collaboration tools by which teams can work together seamlessly irrespective of their location. And it also facilitates some shared access. And so multiple users can access documents and edit them, and they can have access to files simultaneously. So in short, when we talk of some of the real world examples, you could know, we all know that many of the healthcare sector relies on cloud for storing its patient data. And most of the financial institutions like banks and insurance companies also rely on cloud infrastructure, mainly for data analytics purposes or for fraud detection. And most of the e-commerce websites, online retailers, they usually use cloud computing because they can very well scale the infrastructure. We know that during festival seasons, there would be peak shopping, and only a cloud infrastructure would better handle such a situation. And almost all the educational institutions also use cloud-based learning platforms for remote learning as well as collaboration. And media and entertainment also relies on cloud computing. Say, for instance, streaming services like Netflix, they use cloud computing to deliver media and content to millions of users globally. So these are some of the real world uses of cloud. And this is once again the types of cloud as we have seen before. I am just moving on. Now we see why cloud computing is could succeed while other computing paradigms have failed. So cloud computing has actually revolutionized the way businesses operate. It has some advantages and adaptability characteristic than other paradigms, and that is the only reason why it could survive while other paradigms have failed. The main speciality of cloud computing, I would say, is its cost effectiveness, as businesses have to pay only for what the resources they use and they consume, and just because it eliminates upfront investments on hardware and infrastructure, most of the businesses now rely on cloud. And as such, I mentioned that cloud computing is highly scalable, and just because it supports rapid scaling, businesses can handle sudden spikes in their needs. And reliability is also one of the characteristic which made cloud computing to survive than other paradigms. And performance aspects, it is good in terms of fault tolerance, just because providers have some robust measures with them to ensure high availability and downtime. And as I was mentioning before, security measures are also well in place in the cloud computing environment. So providers have invested much on including security measures for the data that is getting stored on cloud, like with encryption or access control mechanisms. And also they focus much on security updates every now and then. And because of that, they could address very well to any of the security vulnerabilities. And as such, innovation and productivity is also one of its um, I mean, characteristic which made it to be successful. And collaboration facility is also possible, with which many of the cloud based tools, people could collaborate and work in teams. And the other aspect, that is when we look at the environmental aspect, um, it facilitates efficient resource utilization, because cloud service provider optimize resource usage, and they even reduce energy consumption and carbon emissions. And these are the limitation, by addressing the limitations with other paradigms. And just because cloud computing offers a flexible, scalable and cost effective solution, it is still prevailing as a transformative force in today's digital age. And these are some of the challenges which cloud computing still has. The first challenge I would say is that with respect to security, there are still incidents of data breaches, where unauthorized access to sensitive information has happened. And there is still some gaps in adopting or following or adhering to the data privacy regulations. And still there is a challenge on protecting data during transit. And another challenge is like we have with vendor lock-in, which means we have to depend on one provider. So here, if we fully rely on any specific cloud provider, then we will not be given that much flexibility to migrate from one to another. And even if we have to do so, then that will incur us a lot of costs. And that is one of the challenges that need to be addressed. And then too much of reliance on network connectivity. As I said, whenever we want to access a resource, cloud resource, then we need to have an internet connection. So at times, if network bandwidth and latency is not up to the mark, then that is going to be a challenge. And then cost management, as I said, we will be billed for what we use. Our usage will be monitored. Sometimes due to resource overuse, we may reach to a point with the we may be billed with some such a huge cost, and it may be quite an unexpected scene for us. And still there is a skill gap. There is not much people with cloud expertise. And we need to invest more on training and development to acquire cloud skills. And these are some of the challenges, and still people are working in this area to address these gaps. And now we look at some of the cloud delivery models. I had already explained what software as a service, platform as a service, and infrastructure as a service mean. So in infrastructure as a service, we provide cloud service provider would give us computing resources. In case of platform as a service, provider would provide you a platform for developing an application. You could test your application and deploy the application. And in case of software as a service, provider will be giving you the software application as such, and you can access the software as a user over the internet without worrying about, I mean, whether our machine has enough infrastructure and platform to install that software. And these are, so now we'll be looking at more looking in detail about IaaS, that is infrastructure as a service. So here we'll see how IaaS actually works. So to start with, the users have to provision their resource requirements. They can provision how much virtual machines they require, how much of storage they need, how much networking resources they require through a web-based console. And after that, users may have to manage their resource as allotted to them, and they can even configure the provisioned resources. And users can utilize those allotted resources in order to run their applications, or they can even store data. And finally, users will be billed based on their resource consumption. So as such, infrastructure as a service is the widely used service just because it is cost effective, it is scalable, it is flexible, and it greatly reduces the infrastructure costs. And next is platform as a service. In case of platform as a service, it is a cloud computing model where developers will actually build their application, run, and even deploy the applications. So here, when we want to have this platform as a service, then users may have to sign up for a platform as a service account. They can provision a deployment environment. Then once provisioning is done, then developers may use this provided development tools and frameworks so as to build their application. And they can even deploy the application on the PaaS platform with just a few clicks or commands. And PaaS provider handles infrastructure management, and so user need not worry about how to scale, or they need not even worry about the security aspects. So when there is a platform as a service, it greatly reduces the time in which the application is brought to market, which means the development would be much faster. And it offers increased productivity in that sense. User need not worry about the development environment. It is cost effective, and it is best with respect to security, and it is scalable. So the popular platform as a service providers are like Heroku. I hope you might have used when we deploy web or mobile applications. We might have used, or we may use Google App Engine for web applications, for building web applications. Or you may have you may use Microsoft Azure App Service for building and deploying web and mobile apps. So these are some of the popular platform as a service providers. So when there is a need to build a web application, or when there is a need to develop and deploy a mobile application, when there is an API development, when there is a need for doing or processing and analyzing large data sets, and when we feel like training and deploying some of the machine learning models, then platform as a service would be the best choice. The third is software as a service. So it is a cloud computing model where software applications will be delivered over the internet. Users can access the application through a web browser, and they need not worry about installing the software and maintaining the software on the local device. So the way software as a service works is that user may have to log into the SaaS application with their credentials given by the provider. Users can interact with the application through a web browser, So data is stored on the cloud provider's server. I mean, the provider, they themselves will do updates. I mean, whenever some security patches are released, everything will be taken care of by the provider. So as such, SaaS offers certain benefits, like we need not buy any software, or we need not worry about how to install and maintain the software. It offers increased productivity, and as such, security will also be to the best. So some examples for software as a service applications are like Google Workspace. Maybe there are plenty of other, say for instance, we have some financial softwares, some project management tools. So all of them fall under the category of software as a service. So next we move on to so this one slide tells you the three delivery models of cloud computing, which we have seen before. So here, so you could see that what are the aspects managed by the provider and what are all the aspects user may have to look into when we opt for any of these services. That is shown in this slide. And now we have some of the cloud activities, like you may use cloud service for any of the following, like service management and provisioning for any of these, or you may go with the security management for any of the following listed below. And you may even think of cloud activities as some of the customer services, like how to make subscriptions, customer assistance, online help, etc. So now we'll see what are all the ethical issues with cloud computing. Though cloud computing offers us a lot of benefits, there are still some challenges associated with it. One is with respect to privacy and data security, which I mentioned before. And I was telling you about vendor lock-in, where one provider would dominate the market, and there will not be much flexibility to migrate from one cloud to another cloud. And even if we could do so, then it would come with huge cost. And data dividing is also one of the challenges or ethical issues with cloud. And we have environmental impacts also with the cloud, like what if data centers consume huge amount of energy, and what if they, I mean, go with a huge amount of carbon emissions. And these are some of the ethical issues associated with cloud. And then we have another issue called data perimeterization. So it is actually a cyber security strategy. So here, what we mean is that it involves moving away from traditional perimeter-based security models to more distributed and a layered approach. So in the past, organizations had their own infrastructure, and they were relying heavily on firewalls and other perimeter defenses to protect their networks. However, now people, instead of investing on their own infrastructure, they go for cloud computing. So the traditional network perimeter has now completely blurred. So why we talk of deperimeterization is that we have increasing number of remote workers, and so it has made, cloud computing has made it difficult to enforce traditional security measures. And just because any people could access cloud service from anywhere, it has expanded the attack surface. And employees using personal devices can also introduce some of the security risks. And there are certain other advanced cyber threats also are possible in a cloud environment. And there are certain privacy issues, which I mentioned before, like we may experience data breach or data loss. And there is lack of transparency control, like users will not have a complete understanding of how their data is going to get used or shared. And data retention, like how much length of time the data will be stored, and how where it is retained. And data portability is also a challenge. And in case, as I mentioned before, it is going to be a pool of resource, and cloud is actually a shared infrastructure. So data isolation and security has to be taken care of. And if suppose cloud providers grant access to some third party vendors for maintenance or support, then the chance of risk is more, because providers need not, could not monitor them all the time. And at times, government will also have the ability to access and monitor some of the data stored in cloud. So all of them poses some of the privacy issues. And there are certain cloud vulnerabilities that had happened in the past, which is listed here. So common vulnerabilities could be like, incorrect settings could also be sometimes bring or invite some threat, and weak access controls. If we have access controls, and if it is not up to the mark, then that will lead to some unauthorized access. And if suppose if we have some insecure interfaces, then there is chance for somebody to compromise the data, compromise and have access to sensitive data. And there is chance for data breach, hijacking. And if the data is not encrypted, then there is more chance of data to be altered. Okay, so these are some of the vulnerabilities which a cloud environment is prone to. So this is one slide where I just wanted to put it here. We were talking of grid computing, which is one of the paradigms, one of the programming paradigms. So parallel computing as such, it is also one of the predecessor. So here, we'll be doing multiple calculations in parallel. So whenever we have a huge problem or a complex problem, we normally think of breaking down the problem into smaller subproblems. And we'll be
Nothing is visible.
No audio and no video.
Sir, please wait. Sir, please wait.
Yes, sir. Yes.
Sorry for the interruption. There was an issue with my network. Yes, Raja, am I audible?
Yes, ma'am. Yes, ma'am.
Can you see the screen?
Yes, ma'am.
Can I start from this slide or should I go back?
Yes, ma'am. Okay, ma'am.
Okay, so Raja, it's fine. Did I start with the slide?
Yes, ma'am. Yes, ma'am. Fine.
Yes. Thank you.
Just a minute. You can go back, madam. Just for a minute.
Okay. Oh, sorry for the interruption. So we were talking about cloud vulnerabilities, and I had added a slide on parallel computing. We know that parallel computing, we normally go for parallel computing when we have some huge task or a large problem to be solved. So in that case, we'll be breaking down it into smaller subproblems, and we will be allocating resources equally to all of those subproblems so that all those subproblems can get executed or run concurrently. So our objective is to minimize the time. And when we talk of parallel computing, we usually talk of Amdahl's law as well. So Amdahl's law actually gives us a way to measure the speed up. So we actually measure it as a ratio of how much time we spend on sequential computation by how much time, what would be the execution time if such a task is given to n parallel processes. So we T of 1 is the time we execution time we expect on sequential or we have one processor where in which we have we have deputed it to execute all those tasks. So here, what Amdahl's law states is that the fraction of time, if A is the fraction of time your sequential program spends on non-parallelizable segments, it means the portion of code which is sequential in nature. We cannot make it run in parallel. Say, for instance, it could be something like taking input from that IO, right? So the portion of if A is the fraction of running time a sequential program spends on non-parallelizable segments, then we say that speed up would be approximately 1 by A. So that is the best tier up, speed up, that is upper bound on the speed up which we can achieve. So here with Amdahl's law, before Amdahl's law, what people thought was that every time people started adding up more number of processors per chip and more number of cores within a processor, right? So we thought that we could expect maximum speed up just by increasing the number of processors or cores. But with the Amdahl's law, it made true, it was proven true that we need not just focus on hardware alone. Rather, we should focus on a portion of code that is actually sequential in nature. So the more the code is sequential, we cannot achieve best speed up. So we need to look at ways to parallelize code in such a way that each of those parallel segments can be made to run on different threads or different cores. Thereby, we may be able to achieve speed up. So the distributed system as such, it was also one of the paradigms of cloud computing, which we saw before. So I'm not repeating the same. So now we move on to cloud data platform. We know that Amazon Web Services, it came into existence in 2006. And by the time it entered world in 2006, it was the first hyperscale public cloud provider. So as soon as AWS was there, almost all the data-driven businesses, they have shifted from on-device or on-premise data storage and analytics workloads into the cloud, and they have gone with adopting a cloud data platform. So almost every business has now shifted its storage as well as analytics workload onto cloud. So here by data, we actually mean the big data, which is voluminous, variety and velocity. So as we have a huge amount of data with us, cloud data platforms with legacy tech as well as complex architectures, they are highly time consuming and they have become very costly to manage. And so data analytics as well as executives are now searching for ways so that they could simplify the cloud platform architecture and reduce the management cost. And also they are looking for ways to eliminate complexity while continuing to realize the full value of data for use cases like, say, for instance, about security or some observability tasks. So by cloud data platform, what we mean is that it is an integrated software solution, so with which enterprise can aggregate their store, process, as well as consume. So there are there are some enterprises who actually deploy pre-integrated cloud data platform products, and there are certain other organizations which actually go with the building modular cloud data solution, and they build modular cloud data solutions, but just by integrating any of the open source or some of the best available technologies. So we know that there are several public cloud service providers like AWS, Google Cloud, and Microsoft Azure. So all of them provide cost-effective object storage for enterprise data. Along with that, they have some scalable compute resources, and they even offer some proprietary cloud services for ingesting, processing, analyzing, and for serving data to the consumers. So I'll be telling you what ingesting, processing, analyzing, and serving. Actually, these four make up the data workflow which we are talking about. So I'll be explaining each of them. So before going into the actual cloud data platform, we'll see what data warehouse is. You may be knowing what data warehouse is. It is actually a huge database. What we mean here is a cloud data warehouse. So as such, in a cloud data platform, organizations usually capture data from multiple sources and they aggregate it into cost-effective cloud object storage. From there, what they could do next is, after ingesting the data, they can go with the normalizing the data or transforming the data from raw format into some relational format, so that we can use any of the querying tools to query and get some meaningful information from the data. So there are many cloud data platforms which have cloud data warehouse. So cloud data warehouse is actually a database. So in a warehouse, we know data will be usually cleaned beforehand, and then it is available in relational format, so that you could use any of the business intelligence or analytics tool to again fine tune the data according to your need. Alternatively, you can even have a data lake. A data lake is nothing but a storage where data will be retained in its raw format. And you can even have some subject oriented data marts also. So you could have either a data warehouse or a data lake or a data mart. So this is the actual architecture, that is the cloud data platform architecture. And these are the 4 layers you find in any architecture, like ingestion, storage, processing, and serving. So now I'll tell you, I will explain you the purpose of each of these layers. So the first layer is data ingest layer. Next to that, we have the storage layer. Followed by that, we have the data processing layer, and finally the serving layer. So in every layer, we'll be having some of the software components, and each of those components will deliver some specific capabilities within the cloud data platform. So first we'll have a look at the ingestion layer. So the software components in the ingestion layer, what they do is they try to serve the function of connecting source systems to the cloud data platform, and then they will start ingesting data from those systems into the cloud storage. So acquiring data from multiple sources is the only function of ingest layer. So ingest layer should have enough tools that facilitate connection to a remote source, and then to gather data and put it in the storage. So data could be, you may have to deal with either real-time data or you can go with some batch processing. And after that, apart from that, in the ingestion layer, you may have to have some tools for data normalization as well as some sort of transformation. So only if we do some transformation after acquiring it from the source, I mean, you could use any of the business analytics tools. Or other option is that you can retain the data as such in its raw format, so that we can even think of some novel ways to, I mean, work on the data. And it also eliminates the need to acquire data from the same source again and again. So that is one of the advantage of leaving the data in its raw form. The next layer is the storage layer. So here in this layer also we'll be having set of software components. So here in the storage layer, public, if suppose we are looking at public cloud vendors, they usually offer the most cost effective object storage. So we have different storage like batch storage, object storage, etc. in cloud, right? So see, in case of I mean, public cloud vendors usually give us the cost effective object cloud object storage. And in that, organizations usually have the flexibility to store large volumes of data, and they can even retain that data for a lengthier period of time. And in addition to being cost effective, I mean, this cloud storage is highly scalable as well as reliable. And so since, as I was mentioning before, the downtime would be close to zero, data storage, I mean, layer actually serves its purpose. And the third layer is the processing layer. The objective of this layer is to read data from storage and then apply some sort of normalization techniques as well as business logic to convert the raw data into a structured data, so that I mean, organizations could draw some meaningful information. And in this, as such, this processing layer will also have some software components which will help data scientists to explore the data. And sometimes by tools we can even have some SQL interface, tools that offer SQL interface, so that you can query the data and apply necessary transformations to the data. And the last layer is the serving layer. The purpose of this layer is to deliver the output to the consumers, data consumers. So the data serving layer often includes a cloud data warehouse, or it can have a data lake, as I mentioned before, or it can even include a data mart. So these are from where users could then fetch the data and use. So these are the 4 layers which actually make up a cloud data platform architecture. So as I mentioned before, these are going to be the key components in any data workflow. First, there will be a data source, that is the place from where your data originates. It could be a database, it could be a file, it could be an API. If suppose you run a e-commerce business, then it could be your you could even have data from your logs. I mean, where you can have the purchase patterns, or if you have some social media accounts, then you may even have some social media stream data, which will actually give you information on trends, right? And the next component is data ingestion, the process by which we actually collect information from the source, any of these sources we mean as data ingestion. So after data ingestion, we can imagine that the data is now available in the cloud facility. After that, we need to store this data. So we have two options: either do some transformation, or you can keep the data as such in its raw form. And after that, the next step, the next component could be data processing, where you could apply any normalization or transformation to further clean data and get it ready for analysis. And the next step is that you could do some analysis on the data, analysis on the pre-processed data, so that you could get some meaningful insights from the data. And then you can even go for some visualization with tools, any of the tools for presenting the findings in some visual format. And final component would be the data output, where we share the results to the stakeholders. So the data output from the workflow will actually help businesses to get some meaningful insights on how the business has progressed so far, and thereby they could make appropriate decision and fine tune. They could do something to make their business flourish. So the first component and the very important component in this data workflow is data ingestion. So here data is obtained from different sources, and here the data, by data we mean the big data, which is voluminous, which has a high velocity, and it will be of variety of data. And as such, you can have data in its raw form in a data lake, or you can have data in a structured format in a data warehouse. And so there are plenty of tools available for for storing data in its native format. Say for instance, Amazon's S3. So it is an example for data lake. And then we have data warehouse like Google's BigQuery or Amazon's Redshift. So these are all some of the data warehouses. And yet another important role played by this ingestion layer is that it ensures the quality and consistency of the data. So it actually helps in, we can even have some data cleaning done here, or we may even have some sort of data validation to ensure the accuracy of the data. You can have some data standardization approaches. So all this can be part of ingestion layer. And for example, when we say, for instance, we have some IoT sensors, we gather data from those sensors, and such data could correspond to maybe temperature, humidity, pressure, etc. And we are gathering data and putting it in cloud. So imagine that we use a data lake. So here the data will be in its raw form. And since as such in a IoT environment, data will be continuous, right? So we say that it is a stream data. So in that case, we may have to use some frameworks like Apache's Kafka for handling the stream data. So once we have the data ingested, and if we do some processing, and if we are able to make some meaningful information after analysis, that would help us to optimize energy consumption in buildings. So this is one of the examples. And next is with respect to data processing and transformation. So here mainly we say that we convert raw data into suitable form for analysis. We may do some sort of cleaning, normalization, and other data enrichment techniques we can apply in order to make the data consistent and accurate, as well as valuable to the users. And the data transformations, for instance, we say about data transformation here. It is actually some form. I mean, we can even convert data from one format to another. That could be also a sort of data transformation. And we have several data processing frameworks like Apache Spark and Hadoop. So Apache Spark is actually a cluster computing system which we can use for batch processing, or you can even use that for real-time streaming as well. And if you want to do some machine learning models to analyze the data, we can use Apache Spark. And then we can even have Hadoop. You know, Hadoop is a distributed storage and it is meant for processing large data sets. So that too fall under data processing frameworks. And for data cleaning, we can say, if suppose the data has some missing values, and if suppose your data contains some outliers, and if suppose there is some inconsistencies in the data, we have some errors that need to be fixed. So in that case, we can think of having some data cleaning. And normalization mainly for eliminating redundancy. So for standardizing the data into some consistent format, we can go for normalization. And by enrichment, we actually mean some adding of some contextual information, like if we add some information, maybe it gives us better context, right? And you can even think of combining data from multiple sources. So all these are part of enrichment techniques. And we have data pipelines. ETL actually represents extract, transform, and load. It is actually a pipeline. So we normally extract data from a source, then transform, and then load it into the target system. So that is what that ETL pipeline refers to. So here, data processing and transformation layer can have even this ETL pipeline. And then data analysis and visualization. We can have some tools for analysis purposes like Python or an SQL. And then we can have some mining tools, and we can even employ any of the machine learning models and techniques. And then we can even have, say, for instance, we can use R for analysis if we want to do some statistical computation. And then we can use SQLs if we have to query and manipulate data. And then we can use any of the mining tools. So by mining, we can employ either association, cluster analysis, regression analysis, etc. We can have any of the machine learning approaches like supervised or unsupervised. And then for data visualization, you could use tools like Tableau and Power BI. So with which we can create interactive visualizations. So all these are possible with the software components and tools available at the data analysis layer. And we have some examples for data visualization like dashboards and interactive reports. And once we have these tools and techniques, then this data analysis tools and visualization techniques, then organizations can extract some valuable insights from their data, and then they can make some data-driven decisions. Say, for example, the same e-commerce example we can take. So in that case, if suppose we are able to make, if we have with us the real-time customer behavior data, like their browsing history or their purchase history, then we can analyze and we can provide some personalized product recommendations to those customers. So that will actually help to boost sales as well as to increase customer satisfaction. Say, for instance, if suppose we are going for, we are using these tools for stock market analysis, then what can be done is that we can gather that stream data from the stock market. We can analyze it. We can analyze for identifying what are all the trading opportunities, and we can even generate some signals. And this will, but the requirement here is that the data processing as well as analytic capabilities should be much faster. Only then we will be able to make some real-time decisions. And then some of the security and privacy challenges. Of course, we have already seen, we know that there are chances for data breaches, chances for data loss, and chances for exposure of data to unauthorized people. And there are some security measures like which we could do is we could adopt encryption both both for the data at rest and for the data that is in transit. And then we can have some access control mechanisms like role-based access control. And we can even in role-based access control, we will be giving access to resources only for users based on their roles and responsibilities. In case of least privilege principle, we will be granting every user only the minimum necessary access to perform their everyday tasks. And you know what multi-factor authentication is. And we have some issues, I mean, concerns with the data governance as well. Establishing a framework itself is a challenge. And then adhering to the standards is also a challenge. So those things will have to be taken care of. And in short, these are the features that are expected from a sophisticated cloud data platform architecture. So apart from the 4 layers which we saw before, like ingestion analysis, ingestion storage analysis, and serving purposes, so there are certain other features which are expected from a cloud data platform architecture. So modern cloud data platforms offer additional features and capabilities that even go beyond those 4 layers which we discussed before. So here they have increased support for batch and handling batch as well as stream data. And they have a tiered storage capabilities. And they have even provision for workload orchestration. And they have a metadata layer. And they have some ETL tools integrated to the architecture. So first, with respect to batch and stream organization, stream ingestion, what we mean is that we have sophisticated platform to handle both batch data as well as stream data. So data streaming, with the data streaming in place, real-time analytics use cases, I mean, when data streaming is in place, some real-time analytics could be done. And suppose, I know, I hope you may be aware of batch processing. And then we go with tiered data storage. In case of tiered data storage, we actually route data through either short-term and long-term storage. With short-term storage, what we mean is that data will be analyzed in the near future, I mean the immediate future. And so such a storage is going to be expensive, but it will support a low latency access. And in case of long-term storage, it is going to be a cheap alternative, but where you can store the data for a longer period of time. And such a data will not be, I mean, analyzed immediately, right? So that is the, I mean, purpose of having a tiered storage. So you could opt for either a short-term or a long-term storage. And then there is a meta layer. So in this meta layer, we actually maintain metadata. Metadata is nothing but the schema. So here we maintain from where we actually acquired the data, what is the status of the data, how healthy the data is. So all these informations will be preserved in that schema. So once we have a metadata layer in place, then what happens is that we need not, I mean, the software components, uh, um, they become highly independent. So it reduces software interdependence. And so because just by accessing this metadata, all the components can get to know what that data is about. So that is the purpose of having a metadata layer. And we have an orchestration layer. So some of the modern cloud data platform architectures have this orchestration layer. In that orchestration layer, they have some software tools like Apache's Airflow or say for instance, if we take Google Cloud, it could be Google Cloud Composer. So all these tools are used to automate as well as coordinate data processing workloads. And with the help of this orchestration layer, I mean, failures would be less, right? And then we have some ETL tools, as I said before, extract, transform, and load. These are very essential for tools for data engineers, because with which they can implement, manage, as well as maintain the pipeline. So we'll see some of two cloud data platform architecture. These are two existing data platform architectures, one with Google Cloud. So here you could see in this architecture, we have some a layer on data ingestion, processing, machine learning, and then insights and activation. That is the output, right? So in this architecture, you could see that structured data from Google, as well as any of the SaaS platform, that is software as a service platform, is ingested directly into the cloud, Google's BigQuery data warehouse. By data warehouse, you need to understand that it is actually a structured data, while the unstructured data is ingested directly into the cloud's object storage. And Google Cloud Platform services like Cloud Data Flow and Data Fusion are also involved in transforming and processing the data. And for workflow workload orchestration capability, there is Cloud Composer. And once the data has been normalized and processed, for marketing analysis, we have separate dashboards. So with the help of those dashboards, people can analyze how the trend goes actually. And with that, they will be able to make some marketing decisions. And even there is provision for re-importing the data after processing into any of the platforms, like say Google Analytics or any of the third-party service, software as a service application like Salesforce. So it has provisions for all, that is for ingestion, processing, using any of the machine learning tools, and even for exporting data to any of the third-party services or other platforms. The next example is AWS. So in this architecture, what we can see is that we have a data ingestion layer. In that layer, we have multiple applications as well as cloud services that actually help in capturing data from various sources. And then the second layer is the storage layer, where we have Amazon S3, which is meant for cloud object storage. And we have natively integrated Amazon Redshift, which is cloud data warehouse. And we have a data catalog layer on top to enable data discoverability. And then we have a data processing layer. In that layer, we have some SQL-based tools as well as big data processing tools. And we have some AWS services like Spectrum, Glue, etc. So once data has been processed using any of these tools, users can then consume the data. They can use any of the analytics services like Amazon's QuickSight BI platform, or they could use any of the machine learning platforms for making further analysis on the data. So as such, these platforms actually help to ingest, process data pre-process the data according to your requirement. And then you could use any of the analytics or visualization tools to capture some meaningful information from those data. And these are some of the best practices. One is that you may have to adhere to data governance. We need to define who owns the data and who is responsible for each of the data set. You need to establish some of the guidelines for who can access and how they can use the data. There should be some retention policies, how long the data should be retained, and there should be some quality standards as well. By quality standards, we mean data should be clean, data should be validated, data should be standardized. And then there should be provision for scalability. we may have to either increase nodes to a cluster, or we may have to increase the resources of an existing node. Both should be possible. And then performance aspect, we may have to focus on data pipeline, and we need to find some ways to optimize it. And cost optimization is one of the best consideration to be made, just because, as I was telling you, we have to choose the right cloud provider who actually align to your needs and budget. And then right sizing of resources is also essential. You need to know how much resource you want, and we have to request or provision only the resources that we need actually. You should not go for over provisioning, because that will incur huge cost for us. And then it is better that we use spot instances. Spot instances are cost effective. And then we have to implement some cost monitoring aspects to regularly monitor our usage. And then we can even think of optimizing the storage just to balance cost and performance. So these are all some of the considerations which any organization or any user should make in order to take the best out of cloud computing environment. So as such, if whatever we have seen so far is that we have seen what cloud computing is, and what cloud computing, cloud workflow data platform, or cloud data platform architecture, or you could say that it's cloud workflow, cloud's data workflow, right? So I was mentioning that in a workflow architecture, we'll be having several layers for ingestion, storage, processing, and serving the user. Say, for instance, if you want me to give a very realistic example, imagine that you have a small e-commerce business, and you want to analyze how the sales goes, and you want to identify some of the trends, and you want to improve your future sales. So in that case, what you will do is, first of all, we will analyze we will collect the sales information. Imagine that the sales information is available to us as an Excel file. Then what you could do is, you could export that data into a pandas data frame, and then read data from the pandas data frame. Then what you could do is, the second step is, so what we have done so far is, we have gathered data from CSV file, and we are getting it, we have made it ready for further processing in a data frame. And the second step which we normally do is some sort of cleaning and processing. Say, for instance, if you feel that the data frame has some missing values, and if you feel that there is inconsistency, then you could apply some transformation there. The third step is, we may have to do some analysis on the data that is held in the data frame. So you could use some sort of exploratory data analysis, like you could get some summary statistics, like what is the mean, median, etc. Or you could visualize how the sales had been with the help of some charts or plots. So you could use matplotlib or something, some other tool like that. And then you could identify some patterns and trends. So that is possible. And further, you can even make some statistical analysis with the help of charts. And finally, as a last step, you could do you could store that information in your storage, either as a CSV file, or you could even store that information in a database. Okay. So this is a very simple application, so which we could do in our day-to-day use. Say, for instance, when we talk about organization, the data they are dealing with will be huge, and it is a necessity for them to go for any of the cloud data platform architecture. And in a cloud data platform architecture, as such, this cloud data workflow applies. So I hope I have done my job. So these are some of the references. That's all from my side.
Participants, if you have any queries, you can please raise your queries to ma'am. Fine, thank you, participants. And one more thing, dear participants, as we have heavy rains in the southern regions, we had network issues, and due to which we had some disturbances in the beginning and mid of the session. We are making all sorts of arrangements to continue the sessions without any hindrances. Thank you for understanding. Now, Mrs. K. Ishwari, Assistant Professor, CSE of Dr. Shivendra College of Engineering, will convey our thanks on behalf of all of us to ma'am, and will also give a preface to the resource person of the next session. Ishwari ma'am, please.
Yes, ma'am. Good evening, everyone. First of all, I would like to say thank you to GJ ma'am for your excellent speech and valuable presence in this faculty development program. Your detailed explanation about cloud computing. Thank you, ma'am. It was very useful to all of us. It is with great honor and excitement that I welcome all of you to this faculty development program. Today, we are privileged to be joined by a highly accomplished professional, Mr. M. Frederick Sujinda, Senior Associate at Cognizant Technology Solutions, and a distinguished leader in the area of software development and innovation. Frederick's journey, spanning over 13 years, is a testament to his dedication, versatility, and passion for technology. From his early days as a junior software developer to holding key leadership roles in companies like Mindtree, Amendem, and Smack Coders, he has consistently demonstrated technical excellence and strategic insight. His expertise encompasses cutting-edge technologies like React.js, Next.js, Node.js, and cloud platforms such as AWS and Azure, making him a trailblazer in the software industry. His accomplishments are numerous, including his victory in the 2024 hackathon, where his innovative problem-solving skills shone brightly. Additionally, his certifications in React.js, Node.js, DevOps, and Magento highlight his commitment to continuous learning, a quality that resonates deeply with the core objectives of this FDP. I encourage everyone to actively participate, engage in meaningful discussions, and make the most of this opportunity to learn from such an accomplished professional. Once again, a warm welcome to all of you. Thank you. Now, I hand over the session to Frederick Sujinda, sir. Please, sir.